Good day everyone. So we are the reporters of microwave technology. Introduction to microwave. Microwave is a line of sight wireless communication technology that uses high-frequency beams of radio waves to provide high-speed wireless connections that can send and receive voice, video, and data information. Microwave radio transmission is commonly used in point-to-point communication system on the surface of the Earth, in satellite communications, and in deep space radio communications. The higher part of the radio electromagnetic spectrum with frequencies are above 30 GHz and below 100 GHz are called millimeter waves. Example of this is the example of cable free. Diversity in microwave links refers by using two or more communication channels with different characteristics. Diversity plays an important role in combating fading and co-channel interference and avoiding error bursts. Diversity techniques may exploit the multipath propagation, resulting in a diversity gain, often measured in decibels. The following classes of diversity schemes are typical in terrestrial microwave links. Unprotected. There is one set of equipment installed and no diversity or backup. So this is the example of unprotected microwave links. Hot standby. One is powered down or in standby mode, generally with the receiver active but transmitter muted. Frequency diversity. Microwave radio links often use several active radio channels plus one protection channel for automatic use by any faded channel. This is known as N+1 protection. Space diversity. It can be achieved by antenna diversity using multiple transmitter antennas, transmit diversity, and or multiple receiving antennas, reception diversity. Polarization diversity. Multiple versions of a signal are transmitted and received via antennas with different polarization.
History of microwave. In 1888, Heinrich Hertz became the first to demonstrate the existence of such waves by building an apparatus that produced and detected microwaves in the ultra-high frequency region. Later work by others led to the invention of wireless communication based on microwave. Diverse path reliant failover. In terrestrial point-to-point microwave systems ranging from 11 GHz to 80 GHz, a parallel backup link can be installed alongside the rain-fade-prone higher bandwidth connection. In the arrangement, a primary link such as an 80 GHz 1 GB full duplex microwave bridge may be calculated to have a 99.9% availability rate over the period of 1 year.
Modern commercial microwave links. A microwave link is a communication system that uses a beam of radio waves in the microwave frequency range to transmit video, audio, or data between two locations. So, microwave links are widely used for connectivity in modern digital IP network with capacities up to 6 Gbps and beyond. A modern microwave links network can deliver bandwidths in reliable, cost-effective, and flexible manner without need for disruptions and delay caused by digging up streets and avoiding costly leased line or leased fiber optic alternatives. Microwave links are commonly used by television broadcasters to transmit programs across a country for instance, or from an outside broadcast back to the studio. So, planning of microwave links. Cable-free microwave links have to be planned considering the following parameters. First is the required distance, kilometers or miles, and capacity, Mbps or megabytes per second. Second is desired availability, target percent for the link. Next is the availability of clear lines of sight between end nodes. Tower or mast if required to achieve clear lines of sight. Allowed frequency band specific to region or country. Next is the environmental constraints, including rain fade. And lastly is the cost of licenses for required frequency bands. So next is the automatic coding and modulations, or ACM. Is a term used in wireless communications to denote the matchings of the modulation, coding, and other signals and protocol parameters to the condition on the radio link. So, in a digital microwave link's automatic coding and modulation uses a rate adaptations algorithm that adapts and modulations and coding scheme according to the quality of the radio channel, and thus the bit rate and robustness of data transmission. The goal of automatic codings and modulation, or ACMs, is to improve the operational efficiency of microwave links by increasing network capacity over the existing infrastructure.
Microwave frequency bands. Microwave signals are often divided into three categories: ultra-high frequency, 0.3 to 3 GHz, super high frequency, 3 to 30 GHz, and extremely high frequency, 30 to 300 GHz. The microwave spectrum is usually defined as a range of frequencies ranging from 1 GHz to over 100 GHz. This range has been divided into a number of frequency bands, each represented by a letter. There are a number of organizations that assign these letter bands, the most common being the IEEE radar bands, followed by NATO radio bands and ITU bands. Automatic Transmit Power Control is a feature of a digital microwave radio link that adjusts transmitter output power based on the varying signal level at the receiver. Automatic Transmit Power Control is a key technology to ensure reliable transmission in all weather conditions, especially in regions with high rainfall and also longer links with fading or ducting. ATPC can be used separately to ACM or together to maximize link uptime, stability, and availability. When the fade conditions rainfall are over, the ATPC system reduces the transmit power again. This reduces the stress on the microwave power amplifiers, which reduces power consumption, heat generation, and increases expected lifetime. Uses of microwave links. A microwave link is a communications system that uses a beam of radio waves in the microwave frequency range to transmit information between two fixed locations on the Earth. They are crucial to many forms of communication and impact a broad range of industries. In communications between satellites and base stations, as backbone carriers for cellular systems, in short-range indoor communications, linking remote and regional telephone exchanges to larger main exchanges without the need for copper optical fiber lines, measuring the intensity of rain between two locations.
Rain fade on microwave links. Rain fade refers primarily to the absorption of a microwave radio frequency, or RF, signal by atmospheric rain, snow, or ice, and losses which are especially prevalent at frequencies above 11 GHz. It also refers to the degradation of a signal caused by the electromagnetic interference of the leading edge of a storm front. Mobile carrier black hole. Mobile black hole refers to the transport network that connects the core network and the RAN, or radio access network, of the mobile network. Recently, the introduction of a small cells has given rise to the concept of fronthaul, which is a transport network that connects the macro cell to the small cells. Low latency network. Cable-free low latency versions of microwave links uses low latency technology which with absolutely minimal delay between packets being transmitted and received at the other end, except the line of sight propagation delay. The speed of microwave propagation through the air is approximately 40% higher than through fiber optics, giving customers an immediate 40% reduction in latency compared to fiber optics.